Hi, welcome to Intermolecular Forces, Solids and Liquids Part 1. My name is Dr. English, and today we're going to start an introduction to intermolecular forces. Specifically, we're going to look at intramolecular forces, intermolecular forces, types of intermolecular forces, why intermolecular forces, why do we need them, and finally, a brief discussion of intermolecular forces and phase change. So let's talk about different types of forces in chemistry. The first one that you should be aware of is intramolecular forces. And what I want you to pay attention to is this first part where it says intramolecular forces. These are electrostatic forces of attraction between ions in an ionic compound and the sharing of valence electrons, in other words, covalent bonding, within a molecular compound. So this is the type of forces that are found in ionic compounds in between atoms in molecular compounds. So we can see this by looking at an ionic compound, like sodium chloride. A lot of times, sodium chloride is represented as one sodium ion and one chloride ion, but really, that's not the case. Instead, what we see is, like here, a sodium ion, Na+1, surrounded by chloride ions, because we know opposite attracts, and every chloride ion surrounded by sodium ions. And it's this positive-negative force of attraction, known as electrostatic forces, that holds this ionic compound together. Now we look at this and we compare it to a molecular compound, where we might have hydrogen with its 1 valence electron and fluorine with its 7 valence electrons. And what we see here is this sharing of valence electrons to form a covalent bond. So fluorine has its full octet, hydrogen has its 2 valence electrons, therefore having its full octet and being stable. These are sharing electrons, while these have a positive-negative force of attraction holding them together. These are known as intramolecular forces. Now in this video, we're going to be talking about intermolecular forces. These are relatively weak forces of attraction that exist between neighboring molecules. So they do not exist in any significant matter in ionic compounds. Intermolecular forces are substantially weaker than intramolecular forces, otherwise known as your electrostatic forces in your ionic compounds and covalent bonding. Only intermolecular forces are involved in changes of state, which we also call phase change. And over the course of these videos, we're going to be talking about 3 different types of intermolecular forces. Specifically, we're going to look at London dispersion forces, dipole forces, and a specific type of dipole force known as hydrogen bonding. So what's the purpose of knowing anything about intermolecular forces? Well, let's take a neutral particle like this blue dot right here. All matter contains at least one type of intermolecular force. As a solid, let's say these all represent neutral particles. There needs to be something between these particles that is holding them together, and that is this concept of intermolecular forces. So there's something that's holding them together. In some situations, we can break those intermolecular forces by adding something like heat. And when we add additional energy, kinetic energy, and raise the temperature of the substance, these intermolecular forces are overcome and they start getting weaker. So as you go from a solid to a liquid, we can see that these particles move slightly farther away from each other. Now, the intermolecular forces still might exist to some degree, but they're much weaker. What you need to notice here, though, in this particle diagram, is that the blue neutral particle itself is not changing. It's not breaking apart. It's not forming something else. It's just getting farther away from its neighboring blue particle. So the intermolecular forces become weaker as we add more heat. And as you can see at the very end here, now we're in the gas phase. And there's no intermolecular force between these particles. The particles are too far apart, and the intermolecular force has become so weak that it doesn't even exist anymore. So as a solid, we see the presence of intermolecular forces. As we add heat, the intermolecular forces become a little bit weaker. And as we add more heat, the particles have so much kinetic energy, they move farther away from themselves, and the intermolecular forces no longer exist. Intermolecular forces are involved in phase change. So here you can see this representing most likely a solid. Okay, there are intermolecular forces to some degree between these blue particles. But again, if I add heat to this solid, it will break apart. Okay, pretty dramatic there. It's going to break apart. The particles are farther away from each other, and we don't have any more intermolecular forces. Maybe to a small degree right here. But as we add heat and we go through phase change, the intermolecular forces are going to decrease. So we'll see this as we go from a solid to a liquid and something melts, from a liquid to a gas as something is boiled, or we'll see the formation of intermolecular forces if we go in the opposite way, as we go from a gas to a liquid as a liquid condenses, as we go from a liquid to a solid and something is frozen. So what we need to keep in mind here is that intermolecular forces play a pretty critical role in the process of phase change. So what did you learn? We talked about intramolecular forces, we talked about intermolecular forces, we talked about different types of intermolecular forces, we talked about why intermolecular forces, and finally intermolecular forces in phase change. Need more help? Feel free to contact me. Have a great day.